Hello everyone. Today we're going to talk about how to name and write the formulas for acidic compounds. First of all, we should discuss what an acid is. A Bronsted-Lowry acid, which is one of the three primary definitions for an acid, is a compound that will react with another and, when it does so, will donate a hydrogen ion, or more commonly known as a proton, to the other chemical species. This is the definition of acids that we will work with. The other two definitions are the Arrhenius and the Lewis acid definitions. The formulas for acids will generally begin with hydrogen in order to indicate that hydrogen is acting in an acidic way. This could be one hydrogen or it could be more than one. It depends on the acid. So, what kinds of compounds are acids? Acidic formulas generally contain mostly nonmetals, including hydrogen. However, you might remember hydrogen is at the top of group 1. It is aligned with the alkali metals even though it is not an alkali metal. This is because hydrogen does share some common characteristics with it, including being easily able to ionize into its +1 cation. So, technically, the acids we will be dealing with are covalent compounds who have a lot of ionic characteristics to them, including how their formulas are written. So, how do we name acids? Acids are named by the anion that is left behind after the acidic hydrogen or hydrogens are donated. In this case, the suffixes that are naturally found for the anions will change. For example, the common suffix on the end of monoatomic, aka the ones from the periodic table, is IDE. When naming the acid, IDE will change to -ic. For example, hydrochloric acid is the acid formed between hydrogen and chlorine. For polyatomic ions, the suffix -ate will become -ic, and the suffix -ite will become -us. If the anion that is left behind after the hydrogen or hydrogens are donated is a monoatomic anion, aka an anion who is found on the periodic table, then the prefix hydro is placed in front in order to help indicate this. And finally, all acids will have acid at the end of their name in order to help indicate that they are, in fact, acids. So let us do an example. What is the name of HCl? First, we should consider what anion is going to be left behind if the single hydrogen that is present in this formula is removed. Chlorine, or the chloride ion, will be left behind by this, and so the chloride will be featured predominantly in the name of this acid. We should consider, do we need the prefix hydro for this acid? And, since this is the chloride ion, what is the IDE ending changed to? Since this was a monoatomic ion, the hydro prefix will be included. And IDE becomes -ic, so the name of HCl will be hydrochloric acid. Let us look at a second example. What is the name of H2SO4? So again, we will consider what anion is left behind when the two acidic hydrogens are removed. The sulfate ion, SO4 with a -2 charge, is left behind after the two acidic hydrogens have been donated. This is one of our polyatomic ions. So we should consider, what does the prefix -ate become? And do we need the prefix hydro? Since this is polyatomic, we will not use the prefix hydro. The -ate will become an -ic. And so the name of H2SO4 is sulfic acid, or you will usually hear it referred to as sulfuric acid. This occasionally comes up with compounds that contain sulfur or phosphorus, where the UR at the end of sulfur or phosphor, or the OR sound of phosphorus, is sometimes included or sometimes not included, basically depending upon what sounds better. So technically either one would be correct, although sulfuric is the one you will hear most often. So, how do we write the formulas for acids? Because we mentioned earlier that acids have a lot of ionic character to them, despite being technically covalent, there will be a set ratio or formula for each of them, just as there was for ionic compounds. and therefore charges must be balanced. Good news here, the only one whose charge really needs to be balanced is the hydrogen, because hydrogen has a +1 charge, which means that if we do our usual crossover trick, we will only ever need one of the anion. It's just hydrogen whose subscript is going to be changing. Subscript for hydrogen will be whatever the charge of the anion involved is. Let us look at an example. What is the formula for hydrophosphoric acid? First, we need to figure out what anion is involved in this compound. I notice the prefix hydro is out in front, which implies this is a monoatomic ion, so it's somebody on the periodic table. And that phosphor part kind of sounds like phosphorus, so this is probably the phosphide ion that is involved here. So we should look at the periodic table and consider what is the common charge of the phosphide ion. Phosphide is a member of nitrogen's family, and therefore its common charge is -3, which means when we go to write the formula, this will become the new subscript for our hydrogen. The formula for hydrophosphoric acid is H3P. Let's look at a second example. What is the formula for cyanic acid? We again must consider what ion is going to be left behind. There is no hydro prefix here. This implies that we are looking for a polyatomic ion and one that has a cyan sound to it. So probably either cyanide or cyanate, since those are the two endings that can turn into ic when you name an acid. So we are looking on our periodic on our polyatomic list for either cyanide or cyanate. Cyanide is an ion that's found on our periodic table, and so it must be that Cn, with a -1 charge, is the anion involved in this compound. Now that we know the charge for our anion, what subscript will our hydrogen need? The formula for cyanic acid will be HCN. Since Cn has a -1 charge, I will only need one hydrogen in order to balance out its charge.